I'm going to take a look at a few position versus time graphs. I got 3 of them here and then an example for you guys to work on as well as solutions to it. So this first graph here is scaled by 1. First question is, what's the initial position of the object? We can find that right here. The initial position of the object will be -3 meters. How far does the object travel in the first 4 seconds? So over the course of 4 seconds, the object is at -3, then it's at -3, still at -3, at -3, and at the 4-second mark, it's still at -3. So it didn't move at all. And how fast is the object moving at the 5-second mark? So we're going to go to the 5-second mark, which occurs right here. What we would like to know is, what is the slope of this line? The instantaneous velocity at 5 seconds is the slope of this line. The rise of this line is 3. The run of this line is 3. So 3 meters over 3 seconds gives you 1 meter per second. Let's move on to the next example. We see another position versus time graph here, again scaled by 1. What is the total displacement over the 10-second interval? So displacement only cares about the initial and final positions. So displacement, delta x, is final position minus initial position. That will be a -3 minus a -2, resulting in -1 meters. The second question asks us, what is the instantaneous velocity at the 3-second mark? So the 3-second mark is right here. This is a horizontal line, so the slope of that line is 0. The velocity would be 0 meters per second. During what time interval from the available times listed below? So this was originally a multiple choice question. This doesn't mean anything to you. During what time interval is the object moving the fastest? So we're looking for the steepest slope. The first line here, the slope of this line is 2/1. So we could say the slope of that is 2 meters over 1 second. The next line, that's horizontal, so 0. This line presented here, that's -2 meters in 1 second, down 2/1. And our final line is down 3/1. I'm sorry, down 3/2. So down 3 meters over 2 seconds. So that'll be -1.5 meters per second. It says, when is the object moving the fastest? So the key word there is fastest. And what that's going to tell us is, it doesn't matter if it's positive or negative. The answer to the last question is between 0 and 2 seconds, as well as this would be 3, 4, 5, so 5 to 6 seconds. It doesn't matter that one's positive and one's negative. Let's move on to our last example. This is going to deal with some accelerations, as we can tell because the line is curved. Just a quick reference of accelerations. Anything that is concave down, like this would produce a negative acceleration. Anything that is concave up, like so, would produce a positive acceleration. Anything that has a positive slope, so that would be this section as well as this section, that's going to be a positive velocity. And anything that has a negative slope, which would be this region and this region, would have a negative velocity. So effectively, what we can do is, if we quarter this circle, we can say the bottom half of the circle is positive acceleration, the top half of the circle is negative acceleration. The right half of the circle is speeding up, and the left half of the circle is slowing down. So the reason why I can make that speed up, slow down claim is the right half of the circle, positive acceleration down here, positive velocity. Those are both positive, you're speeding up. Negative acceleration, negative velocity, both negative, you're speeding up. If we look at the left half of the circle, positive velocity, negative acceleration, you're slowing down. Negative velocity, positive acceleration, you're slowing down. So the top half of the circle is negative acceleration. The bottom half of the circle is positive acceleration. The right half of the circle is speeding up. The left half of the circle is slowing down. So let's take a look at the curves that we have on the graph before we even take a look at the questions. our first one right here, this would match the lower left corner of the circle. So what I can say is that the acceleration is positive, the velocity is negative, and we're slowing down. If I take a look at the remainder of this graph, this looks like the top right corner of the circle. So I can say that's a negative acceleration, a negative velocity. We are speeding up. So, question is, during the first 5 seconds, what best describes the object's behavior? So for the first 5 seconds, we have a positive acceleration and negative velocity, and we're slowing down. During the time of 5 to 10 seconds, what best describes the acceleration? The acceleration is negative. What is the displacement of the object? So the displacement of the object, the only thing we care about is the final position, which is -2, and the initial position, which is +3. So that'll be a -2 minus a +3. That turns out to be -5 meters. That's our displacement. Distance, we travel 5 meters in the negative direction, so the distance is 5 meters total. Perfect. Alrighty, give your example a shot.